Hi everyone, welcome once again. So this lecture is about the layer approach in computer networks, which comes under the subject routing and switching. So what do you mean by layer approach? The layer approach simplifies the complex network interactions. It is essential in the modern scenario to power billions of global users. So if everything is maintained in a single unit, so the establishing the connection, then maintenance and other responsibilities might become very difficult. So the entire structure is broken down into different modules or different layers or different sub layers, and each is assigned a different responsibility. By doing this, the fundamentals of the entire network design and the entire intent operation is managed very successfully. This is one of the very important and very the concept which has to be known and studied by everyone who is concentrating on the computer networks. So, what do you mean by layered architecture? As I told you, the communication into breaking down the communications into different manageable stages where each will be maintained in a very structured way. So, think of it like an assembly unit of a manufacturing of a car where each part is assembled and it goes through into different channels and finally the end product comes out. So, what is the beneficial factors is especially modularity broken down into that is different sub layers. Then interoperability is one of the very important benefit. And whenever something goes wrong, it is easy to troubleshoot and maintain. So this concept evolved from early monolithic network architecture like IBM SNA. So again, we are going to discuss about this OSI layer, which is divided into seven layers. So this is one of the um, primary reference we consider whenever we are going to discuss about the layered architecture. So the first one is the physical layer, where it involves in raw bit transmissions. Next one comes the data layer, where we use frames. And next one comes the network layer, which takes care of the packet routing, and then the transportation layer, which takes care of the end-to-end segments. Then session management, it comes under the managing different sessions, and present layer for the data translation, and application for the data transfer and interoperability. Next comes the TCP/IP model, where the seven layers in the OSI layer is transformed into four layers. So it also takes care of all the seven layer functionalities which we discussed in the OSI layer, but it is here it is partitioned into four layers only. So this is called as the TCP/IP Transmission Control Protocol and Internet Protocol Suite, which was developed by DoD in 1970s. It is one of the practical implementations which is used worldwide, which is also considered to be the Internet model also. So here 95% of the global internet traffic is maintained by this layer, which involves four different sub layers like network access, internet, transport, and application layers. So the upper layers, that is the application and transport layer, the functionality is same like OSI layer, which these application layer handles the user interaction and data formatting. Examples include HTTP and other web-related protocols. Next, the transport layer takes care of managing the end-to-end communication, providing segmentation and offering a reliable TCP/IP transmission, which makes sure that the delivery of the packets in a very prominent and much more reliable way. The lower layers, which is considered to be the network layers, data link layer, and physical layer. So here the network layer focuses on the logical addressing and routing packets using different routes through the middle layers. And next comes the data link layer, which manages the physical and addressing with the help of MAC, media access control, and it also performs error detection so that whenever something goes wrong, the packets are resent. The physical layer is responsible for the raw bit transformations over physical media. So this includes electrical signals. At the same time, by using cables, we'll be using different cables. Nowadays, we are using fiber optics to transfer maximum data. So the key benefits is modularity. So again, breaking down, since we are breaking down into manageable units, it is very, very highly manageable architecture. Then standardization, so it enables multi-vendor interoperability. Like entire products may be different in different countries, so it enables interoperability. And troubleshooting is also very easy since it is a manageable unit, and it also supports diverse underlying technologies. Like new technologies also can be easily added, and it can be easily enhanced. So this forms the foundation of the modern networking. So where it we used to follow a scalable network design, and it also establishes a very formidable global interacting feature. And this also model is essential for network architects, developers, and cyber security professionals. It also continues to evolve. In the meantime, we can see different new technologies come in, which will be helping us to communicate very easily without any geographical boundaries. With this, we come to the end of the session. Thank you. We will meet in the next session.